Now that you're able to do single-step dimensional analysis problems, I would like to show you the utility of dimensional analysis by looking at 2 steps and more. We're going to use this example equation that we've seen many times. Magnesium reacting with hydrochloric acid makes magnesium chloride and hydrogen gas. And we're going to use this as an example to do a few 2-step problems. For the first problem, we're going to look at how many moles of HCl are needed to react with 12 grams of magnesium. The first thing that you should do is make yourself a road map. Where are you starting and where are you going? I'm starting with 12 grams of magnesium. That is my given number. And my end goal is moles of HCl. There is no singular conversion factor that gets me directly from grams of one substance to moles of another substance. So this has to be broken into 2 steps. Let's work backwards. To get from moles of one substance to another, you use the balanced mole ratio. Here, in this equation, the mole ratio is 1 to 2. So I'm going to do mole ratio. That's my mole to mole ratio. Magnesium to HCl. Now that sets the stage for what I need for my first conversion factor. I have to convert from grams to moles so that I can use the mole to mole ratio. For that, I need the molar mass. Now that I have my roadmap, I can set up my dimensional analysis problem. First step in dimensional analysis is always to start with the given number, which is 12 grams of magnesium. Then I will convert it to moles by using the molar mass. The molar mass is found on the periodic table, and because it's just magnesium, that is pretty simple to do. 1 mole of magnesium has a mass of 24 grams. Now here's the glorious part about dimensional analysis. I can just stick my next conversion factor onto the end instead of having to do a whole new dimensional analysis setup. You're welcome to do them separately, but once you know how to do it like this, the math becomes quicker because the setup becomes quicker. Next step is to use my mole to mole ratio. My mole to mole ratio is 1 mole of magnesium to 2 moles of HCl. The thing you really need to think about here is how do I set up my conversion factor so my moles of magnesium cancels out? The only way to cancel a unit is to have it on the bottom of the next conversion factor. So it would look like this. And this is the proper setup that gets me my answer. First thing I'm going to do is check that my units all cancel. Grams of magnesium, moles of magnesium, moles of magnesium, and I'm left with moles of HCl, which is what the question is asking me for. If you cancel out your units before you do any math and get the right thing, then your conversion factors were done in the proper way. If not, if you're left with some random units, you need to reformulate how you're doing this. Next step, I'm going to snake my way through. 12 times 1 divided by 24 times 2 divided by 1. And if I do all this work, I'll end up with 1 mole of HCl. And that's my answer. Now I'm going to show you one more. Question reads, how many grams of magnesium chloride are produced from 18 grams of magnesium? First step is for us to write out our roadmap. Starting with 18 grams of magnesium, end goal is grams of magnesium chloride. In the past, we have used the balanced molar masses to do problems like this. However, that can be very tedious and requires a lot of addition work for the molar masses. So there is a more formal way to do this than using the balanced molar masses. The way to do it is to work through moles. And this is what most scientists will do, is convert things into moles and then convert things out of moles. So we're going to do it that way. That means I need 3 conversion factors here. If the goal is to get to grams of magnesium chloride and I'm saying you have to move through moles, that means the middle step has to be the mole ratio. And the first and the last step have to be converting from grams to moles using the molar mass. Now let me show you what that looks like. First we start with 18 grams of magnesium, and I multiply that by the molar mass of magnesium. In this step, I'm now in moles of magnesium. When you're in moles, that tells you the quantity of atoms of magnesium that you have. And that is the only way to compare with other atoms, how many you have, not the weight of them. The weight is not a good indicator of how many you have because some atoms are much more heavy than other atoms. But in doing a reaction, it's really dependent upon how many of the atoms you have, not how much they weigh. So we're in moles, and that's how we're going to compare. Then I'm going to multiply by the mole to mole ratio. You really need to do this step even if it's 1 to 1. That's how you get from moles of one thing to another. So I'm going to do the full labeling, moles of magnesium chloride, 1 mole to 1 mole of magnesium. I got this from the balanced chemical equation. Now I'm in moles of magnesium chloride, and I'm going to use the balanced molar mass to convert that into grams of magnesium chloride. Before I do any math, I'm going to check that my units cancel. Grams of magnesium, moles, 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 and now I'm in grams of magnesium chloride. I want to make a note here of something that I see often that is the wrong thing to do. When you are doing it this way, where you are using the mole to mole ratio, you use the molar mass always of 1 mole. Do not use the balanced molar mass, or you will be doing a double amount or a triple amount of what you are actually needing for the conversion factor. So let me reiterate. When you are using the mole to mole ratio and molar masses, like 24 and 94, that is the molar mass of 1 mole. When you do it this way, you no longer multiply by the coefficient in the balanced chemical equation, like here. If I were to extend this problem and figure out the grams of HCl, that would be 36 grams of HCl over 1 mole. It would not be 70. I know that 70 is what this is, 2 times HCl, but I already did the doubling here. I already multiplied by 2 when I did the mole to mole ratio. Thus, doing it again here is getting extra amount. So please be very careful of that. If you're going to use balanced molar masses and do it from grams to grams that way, then yes, you do need to double it. If you are using the mole to mole ratio in your conversion factor, then make sure you're only doing the molar mass of 1 mole of every substance that you're using. So let's do some math. 18 times 1 divided by 24 times 1 divided by 1 times 94 divided by 1. And we end up with 70.5 grams of magnesium chloride. There's one more thing that I want to teach you about moles. We know that moles are equal to a molar mass, but what is that equal to in quantity? How many is that? A mole is a counting unit, much like a dozen is 12. No matter what you have a dozen of, it's always 12. I could have a dozen people, a dozen donuts, a dozen cars, a dozen basketballs. It doesn't matter. It just matters that all of those are equal to 12. A mole is the same way. It's a counting unit, but the number is much larger. The number is 6 times 10 to the 23rd. So this could be atoms, particles, molecules, ions, etc. This is another conversion factor. 1 mole is equal to 6 times 10 to the 23 things like atoms. And anytime you have 6 times 10 to the 23 of something, that is equal to the molar mass. So that is another conversion factor to add to your repertoire. You should be able to do the rest of the assignment now. Please take note, it tells you if it's a 2-step problem, and it gives you some hints. Good luck!